Hey guys, welcome to the channel. So today we are going to be discussing equations of motion, and this will fall into your physical sciences syllabus between the grades 10 and 12. So you can be expected to see these questions in papers over the 3 years. So it's good to have a solid foundation right from the get-go. So let's get on with it. There's four major steps that you need to know when answering this question. And I personally use these steps from grade 10 to 12, and I've never had an issue with it. So step one is to write out your variables. So these five variables are crucial when answering these type of questions. So change in time, change in displacement, initial velocity, final velocity, and acceleration. Step two is going to be to assign values to the variables based on the question. So when you read the question, you'll see that they give you the values for certain variables. And then all you've got to do is go and fill in those values. And that'll form part of what you know, right? And then obviously you won't know some of these variables. So most of the time you'll know three of them and you'll have to solve for the fourth one. The third step is to determine the equation of motion. So these are your four equations of motion. So when you write out your variables, what you're trying to do is trying to eliminate which variable you don't have so that you can, based on these equations, you can choose the correct equation of motion that's going to give you the variable that you're solving for ultimately. And your final step is to solve for the unknown variable that you're looking for. But don't stress, I'm going to go through an example with you guys just so you can see what I mean in action. So yeah, it's good to know these four steps of parts so you can apply it in test or exam situations. So let's have a look at this example. So it says a taxi is traveling at a speed of 25 meters per second when a traffic light 40 meters ahead changes to red. Okay, so don't worry about these three questions as well as this final one because you don't have to use equations there. So we're just going to focus on these two. So let's get on with it. So what we're trying to do here is we want to apply those four steps that I showed you guys earlier. So this question says calculate the distance the taxi travels during the reaction time. Okay, so if you read here, it says the driver takes 1 second to react before he slams on the brakes. The taxi then stops within 2 seconds. Okay, so remember step one was to write out our variables. Okay, so let's go ahead and write out our variables. So delta x equals vi equals vf equals, and acceleration equals. Okay, so what do we know our change in time to be for this? Remember this question, it says during the reaction time. Okay, so that it doesn't mean the whole duration of the motion. It's just talking about this 1 second that the driver takes to react. So delta t is going to be 1 second, right? So delta x, isn't this what we're solving for, right? Because it says calculate the distance. And remember, the taxi is traveling in a straight line here. So your displacement and your distance are going to be the same, right? So what I like to do for the variable that I'm solving for, I like to put a question mark, okay? So you know what you're looking for. Vi, what is our initial velocity? It says here, a taxi is traveling at a speed of 25 meters per second. So that's going to be our initial velocity, right? So 25. So final velocity is interesting because remember, this is a reaction time. So when the driver is driving, for that 1 second, he doesn't do anything. He's not touching the brakes at all. So we assume that his initial velocity is actually going to be the same as his final velocity because he hasn't pressed the brakes as yet. It's just a reaction time. So our final velocity is going to be 25 here as well. And we don't really know acceleration. So the variables that we don't know, what I like to do is I've just put a cross on it. So I know that when I'm looking for my equations of motion, I know what equation I'm looking for. Basically, you're looking for an equation that doesn't include acceleration because we don't have that variable. So as you can see here, as I said earlier, you'll usually know three of them. So we know, in this case, we know delta t, we know vi, and we know vf, and we're solving for delta x. So now we're going to look for an equation that doesn't have acceleration, okay? So let's have a look. So it says, so we can see here, this one here has acceleration, this one here has acceleration, and this one here has acceleration. So we don't want to use either one of these three. So what we want to use here is this, because that's what's going to give us. Obviously, different schools may use this notation, but in my school we used this one. So let's go ahead and write that out. So remember now, we did steps 1 and 2. So write out the variables, and step 2 is to assign the values to the variables, right? So step 3, okay, we also did step 3, determining the equation of motion now. So we determined that this is going to be our equation of motion. And now all we have to do is to solve for the unknown variable, okay? So let's go. Delta x equals Vf plus Vi over 2, and then delta t, okay? So now it's just a matter of substituting. So what is our Vf? It's 25 plus 25 over 2, and our change in time is 1, okay? It's very important to take note of the way that I lay the questions out, because the markers will give you marks for writing out the formula, then substituting, and then your final answer. So it's good to lay out your questions nicely. And then obviously, so this is going to be 25, and then multiplied by 1 will give you 25 meters in this case. Don't forget to fill in your units of measurement, right? So yeah, that's question 3.4. So let's have a look at question 3.5 now. So it says, will the taxi stop at the traffic light? Show all calculations. So pretty simple, just follow the 4-step framework. So delta t equals, delta x equals, vi equals, vi equals, vf equals, and acceleration equals. So it says here the taxi then stops within 2 seconds. So that means our change in time for this period here after the reaction time is going to be 2 seconds. Okay, so delta t is 2. Delta x. So here it says, will the taxi stop at the traffic light? So essentially what we're solving for is delta x here, because we want to see whether the delta x that the taxi travels in this 2 seconds is going to be greater than or less than or equal to this 15 meters. So in order for this the taxi to stop at the traffic light, this delta x value has to equal to 15 meters. If it's greater than 15, that means that the taxi is going to go past the traffic light. And if it's less than 15 meters, that means the taxi is going to stop before the traffic light. So this is what we're solving for. Again, right? Same as question 3.4. So our initial velocity here is going to be 25 meters per second. So the initial velocity for this period of the motion is going to be the same as the final velocity at the end of the reaction period, okay? So remember, our final velocity in this case is going to be 0, because that's when the car comes to a stop, right? So when the car comes to a stop, it's going to be 0. And then acceleration, we don't know. So once again, we can just cross that out. So actually, we can use the same formula here. So remember our steps, right? So step 1 is to write out the variables. Step 2 is to assign your data to your variables. Step 3 is to then decide which equation of motion you're going to use. So in this case, again, it's going to be this one, because we don't have acceleration, and we obviously don't want to use an equation of motion that has acceleration in it, because then we won't be able to solve for what we want. So let's go ahead and write that out. So delta x equals Vf plus Vi over 2 multiplied by delta t, so which equal to 25 plus 0 over 2, and your change in time here is going to be 2, right? So what is that going to be? 12.5 multiplied by 2, which is going to give you 25 meters as well, okay? So as we can see here, the distance that the taxi travels from after the reaction time is actually greater than the 15 meters. So what that means is the taxi is going to go past the traffic light, right? So you can write something like So obviously you'll have to write this out in words, but like essentially it's 25 meters is greater than 15 meters. Therefore, um, taxi will not. Therefore, taxi will not stop at the traffic light. So yeah, please like and subscribe if you enjoyed the video, and I'll see you in the next one.